Welcome, today we will seeing roads in Chefland, which is from CODECHEF. Prerequisite for this problem is nothing, we just need math and pattern analysis. The problem statement was to connect cities 1 to n with minimum cost. Cost of any road should be positive. Cost is and of two cities. So there cannot be road if and of two cities is 0. When is and of two number 0, when the binary form of those number have no index which have both 1. Example 1 and 2, have binary 0 1 and 1 0, their end is 0. 5 and 8, have binary 0 1 0 1 and 1 0 0 0, their end is 0. We have to build road from 1 to n. Let's see the binary representation 1 to 7. Let us build some path using them. Roads in 1 to 4. For minimum case the road could be as shown, but we cannot make a road to 4 since it gives 0 with any city. Roads in 1 to 5. For minimum case the road could be as shown, we connected 4 to 5 since their end is non-negative. Here all cities can be connected. Similarly for 1 to 7 also it is possible as shown for minimum cost. But for roads in 1 to 8, we cannot add road 8 to any city, since its end value is always 0.
If you do similarly you will find that whenever we are at n, which is a perfect power of 2, then the result will be -1. Why? Because, when n is perfect power of 2 then only its MSB, most significant bit, will be 1 and number less than n won't have 1 at that index. Example, 8 has 1 in its fourth bit position, any number less than 8 will have at max 1 at third bit. So a path with 8 is not possible. To get the minimum end of two cities, the minimum we can get will be equal to bit value of leftmost 1. Example, 14 to 1110, minimum end value will be 2, which is equal to last set bit position value. 23 to 10111 minimum end value is 1. We can use above analysis since we are including all number from 1 to n.
So now that we know we need to find leftmost set bit of the number and that would the cost for that city. I wrote a code to analyze the pattern. I stored all the leftmost index from 1 to n. Counted the occurrence of a particular index. That is, how many times 1 appeared in 0th index, that is leftmost, similarly for first and second. The output is like, first column is index of leftmost 1 and second column is number of time it occurred. Pattern is, 0 occurs n by 2 times 1 occurs n by 4 times 2 occurs n by 8 times and so on. The n by 2 value is the ceil value. So, 0 occurrence is n by 2, then value will be 2 raised to power 0 multiply count, that is n by 2. Now, that we have known a pattern, that is divide by power of 2 until it gets 0 and keep computing cost. So, let's look into code and understand it. This small code is an efficient way to check if a number is perfect power of 2. You can use any efficient method, but binary operations are faster compared to arithmetic. Link to details of this code is in description. So, first we check, if perfect power of 2 return -1. C. Store total cost. I. Next power of 2 starting from 0. Ceil is taken for performing power, but I performed an integer division of updating n so as preserve the pattern. At last -1 since 1 is always in path, so remove the cost of adding it to cost of path. If you perform n by 2, n by 4, n by 8 then you have to take ceil always and you won't be updating n so no issues there. And that's it. This mathematical analysis reduces the code to log n complexity. The link to problem statement and complete code is in description. You can refer there. Comment and do let me know if you have understood, or state your problem there. Subscribe to keep me motivated. Thank you.